Hello, my name is Tracy Hewitt, and I'm going to present to you my research proposal. My project is called Engineering in STEM, Impacts on Male and Female Elementary Student Engagement. My research question is, what happens to male and female elementary student engagement in science when STEM engineering activities are implemented in the classroom? Some sub-questions are, have third grade students already formed self-concepts around their ability to perform in STEM activities? Are male students more engaged than females in science and engineering activities? Does teaching a STEM unit that focuses on women in the field have an impact on student interest and attitude towards STEM? What about science and engineering turns women off to the field? Can teachers have an impact on this at a young age? Can STEM and engineering activities help male and female students become more engaged in science in general? And what can teachers do to help foster a positive attitude about science and engineering for male and female students? The significance and implications of this project are that the attitude and achievement levels of students in the United States in STEM is a national concern. And furthermore, while research is focusing on STEM and students in STEM, elementary age students are not a major focus in research studies in STEM. So there are voices that are missing. While there are research studies that are on elementary students, which I'll get into a little bit later, there aren't very many. And finally, women are underrepresented in STEM fields, which was a big reason that I wanted to dig into this research. The purpose of this project is to contribute to the body of research on young female and male engagement in STEM and explore methods of teaching STEM that can increase student engagement specifically in females. So I'm going to be focusing on both males and females in this project, but I will be trying to figure out why males might be more engaged than females and what I can do to help engage my female students. The personal significance for me is that I would like to improve my teaching in STEM, and I want to ensure that I'm having a positive impact on female students in their self-perceptions, abilities, and engagement in the STEM field. So, in my research, I found some major themes. One theme I found is the positive impact that early STEM exposure can have on female students. Research has shown that females benefit from explicit teaching of STEM concepts and support and identity development around STEM. Children develop their identities at a young age, including perceptions of self in terms of gender. So here are some examples of studies that found that focusing on positivity around females in STEM can have a lasting impact on female students' identity of self in the STEM field. This first study found that female students' attitude towards STEM was impacted by direct instruction in STEM. Another study found that female students benefited from personalization of projects and direct feedback, which increased their engagement in STEM in general. And finally, this last study found that perception of self is an important aspect in STEM identity development, and females benefited from receiving support in identity development around STEM. So here we can see that females benefit from direct instruction in STEM, which is why I want to explore this more in my project. Another theme I found in my research is that young students have the potential to be impacted by early interventions in STEM. One study found that early interventions in STEM lead to students being more open to pursue STEM careers in the future. And therefore, I'm focusing a little bit on future careers in my project. Another study on preschool age students showed that students working in groups on STEM projects persisted longer, performed better, and had higher interest in STEM, even at a young age. And group projects and hands-on projects are a large part of STEM. And finally, referring back to a previous study that I mentioned, we can see that students develop a sense of self and stereotypes at as young as 2 to 3 years old, making it important to start STEM interventions as early as possible. So these studies show us that early interventions have a strong impact on students. And my hope is to add to this body of research and show that early interventions in STEM are an important aspect of teaching elementary aged students. So the study, these are the participants and the environment of the study. So it will take place in my third grade classroom. I work at a charter school in Asheville, North Carolina. 20 to 30 students will be participating. Some or all may be virtual. There's been a lot up in the air this year due to COVID-19. About half of the participants will be male and half female. These students are predominantly white middle class students, and they've had minimal exposure to STEM and STEM concepts this school year due to the virtual and social distancing environment. So for my research, I will be teaching a STEM unit on engineering and force and motion. Force and motion is a third grade standard that I teach every year, and I developed an engineering unit in a previous course at Western Carolina University, so I'm using it for this project. The unit has 5 lessons in it, and the lessons follow the engineering design process for students, which is over here. We have students will ask, imagine, plan, create, and improve, and it goes in a cycle. And they will be creating a roller coaster. The student goals for this unit are that the students will be able to define force, motion, and inertia, and explain how it impacts the movement of objects. And the students will be able to design and build a product, which will be a roller coaster, that demonstrates the existence of force and how it affects motion. In addition to teaching this force and motion unit and adding an engineering aspect to it, I will also be reading students books about women in the STEM fields and placing an emphasis on the fact that women have the ability to be a part of STEM fields and be successful. I'm going to collect data in 3 different ways. I'm going to start with a pre-unit survey that asks students what they might want to be when they grow up. They're going to draw an engineer and a scientist, and they're going to answer some questions about if they agree, disagree, or they're not sure about science and engineering concepts and ideas. I will also end with a post-unit survey, which will be very similar, but a little more in-depth. During the unit, I will be journaling, taking notes on my students' interactions and how they are doing building their roller coasters, how they're working together. And finally, I will collect student work samples from a packet that they'll be working on in this unit, which is linked on a previous slide. I will analyze my data by looking for common themes, finding places that students have succeeded and struggled, and coding my data. So I'll be looking for students mentioning that they like or love science and engineering, referring to explicit STEM concepts, discussing how they might want to be involved in STEM in the future, and if they have a hate or dislike for science and engineering. And I will be seeing if that changes over the course of the unit. Some limitations of my study are that it's not replicated in many settings. It's only one school, one classroom, and one teacher. It's a fairly small sample size. There is the potential for teacher bias, which I will do everything I can to eliminate. And we're going to be in a virtual learning or a social distancing environment due to COVID-19. Here's the timeline for my project. So I have already secured the funding and collected the materials. I have the STEM engineering unit plan, the blueprint drafted, and the IRB proposal has been submitted. So over the next few months, I'll be finalizing my plans and refining the IRB proposal if necessary. In January, February, I'm going to give the pre-unit surveys, implement the engineering STEM unit, and collect data. And March through May, I will be collecting post-unit data, coding and analyzing the data, and writing the final paper for this project. Future studies could use a broader sample size, be replicated in different settings, such as different schools, states, or with students with different backgrounds. And they could investigate different causes of the gender gap in STEM, such as home life, books and literature, influence on social media, teacher attitudes towards STEM, and student attitudes towards STEM from young ages. So, in conclusion, my literature review has shown that students benefit from early interventions in STEM, and that while females are less likely to enter the STEM field, they are impacted by this explicit STEM instruction at a young age. So, my study seeks to find what can happen to student engagement when STEM lessons are taught explicitly to young students, specifically females. And I hope that it will give me insight into both the attitude and engagement of my students and into my teaching of STEM as well. Here are the references for this proposal. Thank you for watching. Bye.